Eh. Hello, this is Warren Redlick. I am starting a new series of videos. We're trying it out. I call it Argue with Warren. I invite people who like my channel but who disagree with me on something or other along the way to say, hey, Warren, let's talk about this and we'll have a discussion. So I'm calling this the Argue. I didn't put it in the title yet, but I'm going to call it the Argue with Warren series. And David Kinghorn has agreed to come on. And I don't know if argue is really the right term. I think we're going to have a conversation. Argue sounds more fun. I'll argue a little bit. So, people want to argue with me about robo-taxis. People want to argue with me about how much battery a vehicle needs, that kind of thing. David suggested this topic. David and I are both big fans of SpaceX and Mars and technology. David is a software engineer in New Jersey and very passionate about the subject. David is a believer in nuclear power on Mars. Elon Musk has been pretty clear that he believes in solar power on Mars and not nuclear. I'm going to play a clip from Robert Zubrin about that. But before I get into playing clips, before I get into the depths of the argument, David, I just wanted to give you a chance. I just wanted to give you a chance to tell people a little bit about yourself, about why you're passionate about Mars, why you're passionate about solar or space or nuclear. Where does all that interest come from?
Hey, Warren, thanks for having me. Yeah, so I went to college in the early 2000s, and I really always was interested in electrical engineering around power systems, nuclear engineering, space, aerospace engineering. But at the time, there wasn't any money there. So I went into software instead. And my pocketbook is certainly happy with my decision. But I've always had a passion for various forms of engineering around energy and space. And so I've been following both of those fields very closely.
Okay. So the basis of our dispute, if we're going to call it a dispute, and I don't really have a dog in this fight. I support Elon Musk. If Elon says it's the right thing to do, then I tend to believe in Elon. But I don't claim to know. I think I get why he's going where he's going, but I think we're going to learn more from David than we're going to learn from me today. But before we get started, I wanted to play a clip. This is really, if you're an Elon Musk fan, if you're big on the SpaceX Mars mission, I think this clip gives you the Elon Musk side of what the plan is for using. So this is the solar and the brief rejection of nuclear. A little later, we're going to play a clip about kilopower, which is, I'm not sure what David has in mind, but let me first play this clip. This is Robert Zubrin. The video doesn't really, the audio it's from an audio podcast, and I just patched it with a video to make it viewable, make it look better on camera, on video. So here is Robert Zubrin talking about Mars, his conversation with Elon Musk, and the plan to use solar panels, and a brief mention of why that Elon doesn't want to do nuclear. So here we go. Let's see how this goes. Okay, apparently there's no sound. I don't. Thank you for telling me that you couldn't hear anything. I don't know why you couldn't hear that. I don't know how to make it work. So we're going to give up. I'm sorry, I have a couple videos that apparently I can't play, and now I will have to learn how to do that better next time. Robert Zubrin was talking about that he talked to Elon about doing solar on Mars. Elon's plan is to do an initial mission to Mars. Thank you guys. Unfortunately, there's a lag with YouTube that when David and I are talking, you guys don't hear us for about 15-20 seconds. So I apologize. I don't know what happened there with Zubrin, and I'll figure it out for the next time I do a video. So in that video, Robert Zubrin was discussing a conversation he'd had with Elon Musk. Robert Zubrin, who, for those who don't know, is a big fan of Mars. Are you familiar with Zubrin, David?
Yeah, I've listened to all of his stuff, and he is a big nuclear guy, certainly. But
okay, so Zubrin, head of the Mars Planetary, what is it called? The Mars Society, Mars Planetary Society?
Yeah, the Mars Society.
Yeah, so Zubrin is a big advocate for going to Mars, and Zubrin talked to Elon about the power requirements for having a starship to refuel on Mars. There's this concept called in situ resource utilization, that humans, or that we'll fly to Mars, we'll use water and we'll use solar power, and I'm not sure what else, in order to create fuel.
The carbon dioxide in the atmosphere.
Okay, thank you.
So you get the carbon from the carbon dioxide in the atmosphere, the hydrogen from water, and you create methane.
Okay, and then oxygen,
and that's your fuel.
And then oxygen also, right, from the H2O, from the H2O,
right,
and the CO2,
and the CO2, right. Yeah, both.
So they're able to create methane and oxygen to create fuel for Starship to fly back. And the argument that we're going to have is partly about what energy source would be appropriate for generating the power to do this. What's it called? The Sabatier reaction. Is the solar method is the. I think both of them involve the Sabatier reaction, where you use energy to convert. Am I correct about that? You're using.
Yeah, that I believe so. That's correct. Yeah, so you just need an energy source. It doesn't matter.
Right. So Elon's plan is to use solar. Zubrin likes the idea of nuclear. So Zubrin told Elon, well, you're going to need 6 to 10 football fields of solar. And Elon said, well, that's what we're going to do. And Zubrin just casually mentioned that Elon doesn't like nuclear. So I did a little research, and I think you guys will be able to. I did a little research on kilopower. He made a reference to each football field would generate 100 kilowatts of electricity. And I believe I believe that would accumulate, over, let's say, a 10-hour day, that would accumulate a megawatt hour of power. Is that? I don't know the math here. Dave, does that sound right? If you have 100 kilowatts,
yeah,
and it's efficient.
Right. Yeah. So I was mostly looking at base power, like power for your base
to run the colony,
100 people or however many.
Power to run the colony, right, the life support systems.
Yeah. Right. So I think there's a big difference between what you're using it for, if it's for your colony versus if it's for generating power to refuel your starship, as far as like reliability and battery backup and stuff. So yeah, I'll let you continue, but I think there's a big difference between those two.
Okay. So anyway, the idea is, if the goal is to be able to refuel a starship so that people who are on Mars can come home, which is a big goal, then you need to generate a lot of energy so that you can convert the water and carbon dioxide in the atmosphere to methane and oxygen that can be used to fuel the starship's return. Okay, and then kilopower, I'm going to put a slide up that David can't. So does that sound about right to you, David?
Yeah, exactly.
Okay, so a 10 kilowatt kilopower would be generating 1/10 of the power that a football field of solar would be, according to Zubrin's characterization that a football field, and I read this somewhere else, that a football field of solar would generate 100 kilowatts. One of these kilopower units would generate 10 kilowatts. So would you, just for a starter, so we're on the same page here, would you need 10 of these 10 kilowatt kilopower stations in order to generate 100 kilowatts? Is that a fair comparison, or am I missing something?
Well, right. So I approached it a little differently, and I'm looking at the just from Tesla's website and then Kilopower's website. If it takes 3,500 pounds, so that's 1.65 tons, and a Starship supposedly can do 100 tons, it's 1.65 tons for 10 kilowatts of this of the kilowatt reactor. The equivalent of solar panels would to create around the same amount of power is something like 2 tons. So if you're I'm just thinking about weight, because I think that's all that really matters when you're talking about shipping stuff to Mars. It doesn't really matter how much it costs to create the thing on Earth. It's how much weight do you have to ship to Mars. So just as solar panels, I think it's slightly heavier than the kilopower. But yeah, in order to do a full Starship, you would need several smaller reactors, or you could do one bigger reactor. And then they were doing research into, although they haven't fully designed it yet, a megapower reactor. And of course, then that's a whole new ballgame, because solar scales linearly and nuclear scales logarithmically. So to get 1,000 times the power, you don't need 1,000 times the weight. You need like 30 times the weight.
Sorry, let's be clear. Let's be clear about this for a second. Just on the first point, a ton of solar panels would generate slightly less power than a ton of kilopower reactor. Am I getting that right?
Yeah, but it's right. So this is on Mars. Yeah. So remember, Mars is further from the sun than the Earth is, about twice as far. So you're going to have less sunlight, and like Earth, it has a 24-hour and 40-minute day. So depending on the season, it could get slightly less or slightly more light, than half the time.
That also depends on where. That also depends on where they located on Mars, right?
Correct.
Okay, and then just to be clear, there's no clouds on Mars. There's no cloudy days, but the kilopower reactor runs 24/7.
Correct. There's no cloudy days, but there are dust storms, and they could not only clutter block your panels for a few days, but leave dust afterwards that you're going to have to send a Roomba or whatever to clean off before you can use them again.
Yeah. Does the dust generate that much of a problem?
Yeah, it could. It's just like any dust here on Earth, right? It's not going to. So the winds can be up to 200 miles an hour, but since the atmosphere is 1/100th that on Earth, it would be like a 2-mile-an-hour wind. So it's probably not going to blow over your solar panel or do much damage, but it could, create a thin layer of dust on it that you're going to have to go dust off, or sends a Roomba to do it.
Okay, so you mentioned something about logarithmically with nuclear power. So solar scales linearly. If you put twice as many panels out, you get twice as much electricity. If you get a nuclear reactor, you take a kilopower device and you make it twice the mass. Do you get twice as much energy, or do you get more than twice as much energy, or less than twice as much energy?
You get more than twice as much energy.
Okay, so
linearly in terms of weight. Logarithmically in terms of the increase of weight per power.
Okay.
So the if you look at the mega power design, which was similar to kilopower, although it's not as far in development, but the goal there is to have a 10 megawatt reactor that you can fit on an 18-wheeler. And so that's around like 40 tons.
Okay, so that's something that, in theory, Starship could deliver to the Martian surface.
Right.
That a Starship that can deliver 100 tons can deliver 40 tons.
Yeah, so it could deliver possibly 2 or 1 and a bunch of other
Okay, but
stuff.
1 would be a lot. It sounds like what you're saying is one that's doing 10 megawatts.
Well, it depends how many people you have, right? If you're bringing 10,000 people, then it's not that much. But if you're bringing 20 or 100 people, then yeah, it's
okay.
a lot.
So I mean, as I look at it, if Zubrin says Elon needs 10 football fields of solar panels, and a solar panel field, a football field generates 100 kilowatts, then 10 generates a megawatt. You're talking about one device that would generate 10 megawatts. And it would generate 10 megawatts 24/7, not just when the sun is shining, and it wouldn't get covered by dust. So the argument for nuclear is pretty strong on that context. That sounds like a pretty strong argument for nuclear, but of course it's not ready yet.
It's not ready yet. And the other issue is, and this is maybe why Elon Musk doesn't like it, is because he can't legally build it. Because even the smaller one he can't build, because it requires the use of, this is a sodium stovepipe reactor. So it's very compact, which you would need if you're going to move it to Mars, as opposed to the pressurized water reactors that we mostly use on Earth, which are bigger and operate at a lower temperature. And you could potentially eventually build those on Mars, because I think all the materials are there. There's uranium, there's water, there's steel and stuff. But this particular reactor requires highly enriched uranium, like weapons grade uranium.
Oh, not U-235. It requires U-238.
No, it is U-235, but it's a specific version of it that is highly restricted.
Okay.
So a commercial reactor, a nuclear operator could not build this. It would be illegal. So you need a government to do it, either NASA or Space Force, I guess, or the UK could probably do it, France.
Okay, just
Russia, but let's not go
just to cut you off. Space Intelligence says that he thinks Starship will only be able to deliver 50 to 40 tons to Mars orbit. I don't know if you mean Space Intelligence. I'm sorry. Do you mean to the Martian surface, or do you mean only to orbit? Because a reactor in Martian orbit doesn't help a whole lot. We need a reactor on the Martian surface. I think my impression was they would be able to deliver more than 40 tons to the Martian surface, but I could be wrong about that. Do you have a sense of that, David?
Well, no, I heard the same as you did. I mean, I was looking at 100 tons from Earth to Mars if you refuel it, 7 times or whatever. In orbit,
the tankers refuel the Starship in orbit before it leaves.
Right.
I believe that's correct.
Right. So to do the 10 megawatt one, well, again, it still doesn't exist. So, but yes, he would need to be able to deliver around 40 tons from Earth orbit to the surface of Mars.
Okay, so
but again, if when they designed Kilopower, they were not anticipating Starship. They were looking at launching it on an SLS or something. So that's why they were making it a lot smaller. If we know how much Starship can deliver, I'm sure they can design a reactor around that.
Okay, so my guess is that one of the concerns is that the public perception of nuclear power is people are scared of it. I think we're already launching nuclear devices into space, aren't we?
Yeah, so I think some of the, Voyager and a lot of spacecraft have launched with essentially nuclear batteries. So it's not a full-blown reactor. There have been a couple. I think the U.S. did one, and the Russians did 2 reactors into space. The general guidelines are that So these were on spacecraft. So the general guideline says you're not allowed to fire up the reactor until it's out of the Earth's atmosphere. So like 350 miles up, completely away. Then you could fire it up. And this is for space nuclear propulsion, which is not what we're talking about here. But so you can use that to go, to Jupiter or whatever, or Mars. What we're talking about here, you're not going to turn on the reactor until it lands on Mars. You unload it, and then you turn it on.
So is there a perception, though, that you've got, let's say, 200 kilograms of uranium-235 on a starship, the starship blows up, and you're getting 200 kilograms of uranium-235 sprayed over the Earth's into the Earth's atmosphere? It's not plutonium, right? That's not as dangerous as some other things, right? Tell me what the danger is there.
Yeah, right, correct. I mean, it's not. It's certainly not going to ignite. I mean, it's not going to create a nuclear explosion at all. Yes, it could potentially. They use depleted uranium in. They've used it in bullets and other munitions in Iraq and Afghanistan, and some people have claimed that it caused respiratory problems or something.
Well, if you put a hole in someone's lung.
Well, no, not from that. Just from some of it coming into the air and then breathing a small bit of it. Yeah, so it might be a small carcinogen, but I think if the thing explodes, I don't think you're going to get a whole lot of that spread around. I think the explosion itself is going to be more of an issue than the small amount of particulate matter that might be spread around your launch site or whatever.
Okay, and then the other question I have is, we have problems on Earth with nuclear waste, and we have nuclear reactors that produce waste, and then we don't know what to do with the waste. Does a kilopower nuclear, what happens to the uranium as fission occurs? What are the waste products of these kilopower devices and megapower devices?
Right. So it's all basically the same as on Earth. The amount of waste is, I think, overblown in nuclear in general. It's the amount of energy of uranium that it would take to power all of your activities for your entire life can fit in a can of Coke, and the amount of waste can fit in that same can. So per person, we're talking, even if you have 1 million people on Mars, it's like a very tiny amount.
But is it
that we're talking?
What is the waste? First of all, I mean, does it create plutonium? Does it create what are the waste products of a kilopower? What is the chemical composition of the waste products of a kilopower device? Is it just more thorium? Is it some kind of radioactive material? It's not creating plutonium, right? We're not talking about plutonium.
No, I think it's something along uranium-238. I would have to check. I don't have the. I don't have it.
And is the idea that the device keeps the waste in itself?
Correct. So these devices are meant to last for at least a dozen or maybe a couple dozen years. After that point, either you can just retire the whole device, or you could, which probably on Mars, at least initially, you might just say, okay, this device is done. We'll just bury the whole thing and send another from Earth, or replace it with solar panels that you manufactured using your nuclear energy or something. But potentially you can, potentially you could refuel it. Although I think if you're going to mine uranium and create nuclear power on Mars using in situ resource utilization, you're probably going to just create light water reactors like we have on Earth.
Okay.
Just because that's
easier. We have
easier,
a comment from Eldon Crom who says uranium-235 30%, CO2 coolant, and Bryanton cycle turbine 13 megawatts is around 40 tons. I'm guessing a Bryanton circle turbine is different than the kilopower model that would be used to create the megawatt reactor you were talking about. or is that the same thing?
I think it's slightly different, but there's a whole bunch of different ways to do this. I think this. I think it's fairly similar.
Well, isn't a turbine where you're spinning? You're creating something that, I mean, is that maybe the kilopower is doing this too? Are they creating something that spins to generate electricity?
Yeah, we can look at the article again, but I don't have it right.
Okay, that's all right.
I think it's similar. Yes, I believe it's some sort of turbine. I don't know if it's the one he was talking about or something slightly different.
Okay, so I think Eldon is saying that the Bryanton cycle turbine he's talking about would weigh about 40 tons, and that is something that's already planned for Mars, but it would need to be legalized, which suggests that somehow it's currently illegal. Eldon, if you don't mind commenting, what's Eldon, what's the legal status of nuclear power on Mars? Maybe you can answer, David.
Yeah, the Mars Nuclear Regulatory Committee, I'm sure, has very strict requirements on that, since it doesn't exist.
No, it's not. It's not whether Mars has. It's whether we have treaties with other countries, or whether NASA or some federal agency has said we can't use nuclear power in this context. There could be a variety of reasons why it might be illegal. I don't know what Eldon's referring to when he says we need to legalize it. I don't know if you're familiar with that.
Right. So, yeah. So the again, creating any of these kind of reactors that are dense enough that you would want to transport it to Mars, that is not something a commercial company like SpaceX or any existing reactor company can create, because it does use this highly enriched uranium.
Okay, so government would have to create it. Eldon is saying that this particular type of reactor is not legal in the U.S. So you wouldn't be able to create it in the U.S. So here,
yeah. So there are some options. First of all, right. So probably NASA or the Space Force or something would create it. I think it comes down to this. If Elon is serious and he says, okay, we're sending 100 people to Mars in 2026 or
2025,
whatever,
yes.
Then then I think everyone, well, if it's just 100 people and you're just going to go there, do a little bit of science and come back, and you just need enough, solar panels to power your reactor and do a little bit of science and, to power your return vehicle, do a little bit of science, and then you're going to come back, then yeah, you can probably get by with solar powers and a bunch of batteries.
Let me just interrupt for a second. I just want to be clear. I believe that the initial mission in, say, 2025 would be a lot fewer than 100 people. I think we're probably talking about no more than 10 people and maybe only 5 people as sort of the initial, let's get people to Mars mission. And then it's really 2027, I think, when you would have a large thing. And I just wanted to, let's turn to solar for a second before we get back, before we keep talking about nuclear. I think that, and Space Intelligence agreed with you that dust would reduce the efficiency of solar panels, and then the time of year could make a big difference as well. I think the thing is that the concern about the cost of delivering mass to Mars, that the big advantage, it sounds like, of some sort of nuclear kilopower, megapower approach is you're getting a lot more energy, a lot more consistently over time for a lot less mass on a larger scale, if you're going to do this larger scale project. I think one of the big ideas of Starship is we're reducing the cost of delivering mass to Mars, so the cost of delivering extra mass to Mars doesn't matter that much. We don't mind spending more money on mass. And then you have the second problem, which is we haven't really developed the reactor that we're comfortable sending yet. And the history of nuclear power is it takes a long time to develop the thing you want. It's not like we're going to have the right reactor developed in if we start now, we're not going to have the right reactor developed by 2025. So it's not realistic to think that'll be ready in time. Where solar panels are easy.
Right. So I think what's going to happen is when Elon says, okay, 2025, we're serious. We already landed some cargo on Mars or whatever. We can refuel starships. We're going. I think at that point, yes, I'm sure there will be solar panels and batteries. I think at that point, probably the NASA kilopower people will say, hey, look, we have this thing ready to go. We've tested it a bunch. Can you fit it on? And we'll just see how it works. And if you don't need to use it, that's fine. But let's try it out. And then if it is effective, then maybe next time. And if we keep doing this and have more and more and more people, then we'll put something more substantial. But probably the first one, I would think they would try to put a small reactor that they already have tested and just see how well it works actually on the Martian surface.
Let me just,
I mean, that would be.
Let me just ask a quick question here, because there's a question from, or a comment from, forgive me if I don't pronounce this right, Mr. Salim. I think it's Afak, but I could be pronouncing it wrong. AFAQ. Is there any study done on using molten salt thorium reactor? I believe it will be a high temperature reactor. Will be able to use radiation coolers. And this actually led me to a question that I was going to ask. One of the concerns when you're in space is you've got to manage your heat. On Earth, we have a lot of ways of cooling something that gets hot, you know, from air cooling to liquid cooling or whatever. If you use a nuclear reactor, if you use something in space that generates a lot of energy, it often generates heat, and you have to find a way of dissipating heat. Is that an issue on Mars, or is it, because I would assume that would be an issue with nuclear power on Mars as well. Is there enough atmosphere that it dissipates heat on its own? Are these things going to overheat?
Right.
How does that work?
Yeah. So the Killer Power project, that is meant to be done in space. So that can be done on the moon. It could certainly be done on Mars or in open space. So that's not an issue. If the thorium molten salt power plants, they don't have those really on Earth yet. That's still kind of a theoretical design for a bunch of reasons. That could be a possibility. On Mars, yes, the atmosphere is going to cool it a little bit. But the other thing is you have, I mean, depending on where you land, but in many places on Mars, there is a ton of ice underground, like in the same way that there are water tables under large parts of the Earth, there are ice tables under large parts of Mars. So you could certainly use some of that ice as a coolant.
Okay.
And as a byproduct, you would get desalinated water, which is a nice thing to have in general.
Okay, now Space Intelligence, who I'm a big fan of, brought up this. He said something that actually brought up something I was concerned about. I want to bring up. This is, to me, a negative for solar, but he said, I think at first Elon will start with a massive solar farm with batteries to help store extra power while it's not being used. And this actually struck me as a major concern. If you're just using solar and you run the Sabatier process while the sun is out, no big deal. If you want to run the Sabatier process at night when there's no sun, then you need batteries, but batteries weigh a lot. And typically, when you're doing energy, batteries for grid storage, let's say, you're less worried about energy density by mass or any energy density, because mass and volume don't matter that much in a project like that. But in cars, energy density matters a lot, and I would think for Mars, if, okay, now we're going to send a megapack to Mars, well, how much does a megapack weigh? Now you've got to throw that weight in there as well. Do you think that a solar project on Mars will need batteries as well? Or do you think, I mean, I would think for operating the colony, you're going to need batteries.
Yeah, so that's where I said at the beginning, it really depends if you're going to use this just to refuel your Starship, in which case you've got 1.5 years to refuel the Starship. You can just do it on sunny days. That's fine.
Yeah.
You don't have to run the process the entire time. And methane, oxygen is a great energy store. So you can do, I mean, it's inefficient, but it doesn't leak the same way hydrogen does, and it doesn't dissipate the same way batteries do over time. So if you're just refueling your Starship, I think solar panels are a good idea. If you're doing the colony, then I said at the beginning, it's going to take probably around 2 tons of solar panels to create 10 kilowatts of electricity. But if you only get that during the day. And if you're using it to power your colony, you also need it at night, obviously. So if you're having 24 hours of battery storage using the Tesla power packs or mega packs, then that's another 2 tons just for 24 hours. And then if you're a little more conservative and you think, well, what if we have a long winter? What if there's a bunch of dust storms back to back? And we need to, go out and send someone out to clean them up. And, we could be up to like, a week, possibly, assuming the batteries are all fully charged and don't dissipate. And if they are, maybe we need up to 2 weeks. So if you're going to have 2 weeks of battery backup, then in addition to your 2 tons of solar panels for 10 kilowatts, you need 28 tons of batteries versus your 1.65 for the 10 kilowatt kilopower reactor. So then you're at like a 40-to-1 ratio.
Yeah.
So
explain the dust storm concept to me, because I saw the movie The Martian, and there's this dust storm, and I have this impression that the Martian atmosphere...
It's not going to knock over your ship. It's not going to knock over
I have this impression that, okay, the Martian atmosphere is really thin. It's not going to knock me over either. That, a dust storm is not going to be that much of a problem. And if there's a dust storm, you'd be able to go out and clean the dust off in the middle of the dust storm, wouldn't you? Whereas, is the dust going to accumulate so fast that you wouldn't be able to keep it clean fast enough?
I don't know the answer to how fast it's going to accumulate, like as far as, number of millimeters per, hour or day or whatever. That's a good question. Maybe one of your listeners knows. But yes, I mean, you would need someone with a duster to be running around your 10 football fields of solar panels.
You think they use the robot? You think they use the robot dog? What is it? The Boston Dynamics robot dog. You think they can train that to clean dust off the panels?
Well, they're working. NASA's working on a helicopter for Mars, so maybe you could have a little drone that goes and does it. I don't know. There's some options.
A drone with a duster. A little duster attachment.
Yeah. Yes, absolutely. That's a possibility. Again, if you're just doing it for refueling your Starship, you can just wait for the storm to end, then send out someone in a spacesuit or a drone or something to clean it off and then get back to business. If you're using it for power your colony, then you're kind of like worried, like, when is this going to end and stuff like that. Whereas I think it's likely or possibly desirable, even if you are using solar panels mostly, to have like one of these 10 kilowatt kilopower plants in like an emergency storm shelter. So if things do go wrong, everyone go down to the storm shelter. You could just wait it out down here. And then when everything's all clear, then you go up, clean up the mess, and get back to business.
I just want to address Space Intelligence had another comment where I think I disagree with him on this. He said, what about the breakthroughs? Thank you, Afak. What about the breakthroughs with solid-state batteries? Solid-state batteries could greatly reduce the weight of transporting them to Mars. And I think the issue with solid-state batteries is, number one, like molten salt thorium reactors, that technology is not really well developed yet. And there's 2 issues with battery technology. One issue is energy density. Yeah, if you had solid state batteries and they had better energy density properties and you got to 500 kilowatt hours per kilogram or whatever, if you, not 500, I think 500 watt hours per kilogram, that would be better, yes, but you need cycle life, because if it only lasts 100 cycles, that's not going to do it. And right now, Tesla has batteries that will go for 4,000 cycles or more that they're currently using in Tesla energy. So if they only last 100 cycles and you have to send more, then that's not efficient. You would have to get solid state batteries that have high cycle life. And I think the solid state battery technology that might make this work is going to be a long ways away. I think one thing I want to stress, the big thing about Starship is, if they're able to produce 2 starships a week, if they're able to manufacture starships for low cost, if the fuel is low cost, if they're able to use methane and oxygen, and it just costs a lot less. And they may even be able to make their own, using the Sabatier process, make their own methane and oxygen here on Earth. The cost of delivering volume and mass to the surface of the Mars becomes a lot less. And while honestly, you've persuaded me quite a bit, David, that nuclear makes a lot of sense. If Elon can get the cost of of transport down, the cost of transporting both mass and volume to the surface of Mars, so that you can deliver 10 football fields of solar panels, if you can deliver 100 football fields of solar panels, if you can deliver multiple megapacks as backup, if you're able to get that cost per kilogram down, because here's what I don't know: how much is this 10 megawatt nuclear plant going to cost? And Elon's thing is producing volume. He doesn't want one of them; he wants 100 of them. So how much is it going to cost him? Whatever you don't make things efficiently if you only make one. So he can manufacture solar panels in volume and get the cost down, and get the cost down, and get the cost down. He can manufacture starships in volume. He can manufacture cars in volume. If you're just going to make one 10 megawatt hour, 10 megawatt plant, that's going to be a really expensive item. It's really about, can we make more of them? Can we make them faster? And I don't know that fits with the model that Elon tends to follow. What do you think about that, David?
Yeah, so I think that's a really good point. I think I don't think the cost matters that much, because again, this is going to be have to be done by a government. So Elon's not going to be paying for it. It's the taxpayer that's going to be paying for it. So it'll have to be somewhat of a political thing. But and so presumably that would be NASA or whatever. So the question would be, when Elon wants to, go on 2025 and then 2027, and how many, if any, nuclear reactors do they have ready to send?
Right. Well,
so
I think you made a key point here.
That's what it's going to come.
You made a key point here, which is Elon does not look. We just saw what happened in Alameda County. Elon does not want to rely on government for his mission to work. If he has to rely, that may be the fundamental flaw of the nuclear power hypothesis. Is if you said, "Hey, Elon, you could set up your own factory making kilopower plants," and he could hire nuclear engineers to make them, and they could make 100 of them. They could start making one a week, start making two a week. Right. Then I could see Elon going for it. But if they're not going to let him do that. And maybe he solves the logarithmic problem better than maybe he's able to get the mass down and get them more efficient. But if he has to depend on government saying, "Okay, here's your nuclear power plant that you can take to Mars," it's going to take too long. They won't have that thing ready till 2040.
Right. So I think maybe the most important thing that Elon is doing by saying we're going to do this all by solar power is basically tell the NASA and all the other governments, hey, the bus is leaving on this schedule. Either you're on or you're off. And if you're on, you need to, contribute something. And so maybe that's a nuclear power plant. Maybe that's some life support system. Maybe that's some other technology. Maybe it's just money. But I think if people are serious about it, then I think it's going to light a fire under not just NASA, but France has an excellent nuclear program, and they do it in bulk. They don't just create one reactor of one type. They do a couple of dozen of them, and Britain is just starting to do this. They're developing a couple nuclear reactors in this next decade, and I'm sure they can scale it down to do something for Mars, and probably even Canada could. So I think if he sets off this next space race, as far as we're going to Mars on this date, all aboard, and either bring stuff or don't, we're going to do solar panels unless something better is presented to us, and then we'll use that too. I think that's going to set off a new nuclear race to develop these reactors.
Okay,
but I do. That's just my maybe optimistic or
Okay,
hope.
I just want to point out, let's just talk for a second about why this is so important. So, first of all, one of the principal uses of generating energy on Mars is for the Sabatier process to generate methane and oxygen so you have fuel to get home. Another big thing is life support. You've got to be able to power the living environment for these astronauts who've come to Mars, and eventually colonists who've come to Mars. So that's another reason you need it. Now the next thing is a couple of comments here. Eldon mentioned the Boring Company, and somebody else, maybe it was Eldon, also mentioned using a bulldozer. You're going to need equipment on Mars to accomplish things. And one of my theories, I have a video about this, is I believe that that SpaceX is going to bring Boring Company machines at some point to Mars and bore tunnels underground. And the ideal Martian habitat might very well be underground because you're protected from radiation. But the energy used by a boring machine is very high. Eldon, I think, said it was 1.4 megawatts or something like that. So, and if you want to do any kind of, think about all the work we do on Earth, building buildings with concrete, some way or other, we're going to have to create structures. We're going to have to, or we either have to create above ground structures on Mars, or we're going to have to create below ground spaces on Mars, or both. And all of that takes a lot of energy. And then, suppose you want to make a pizza. Well, you got to have an oven. It's got to generate, get up to a certain temperature.
A greenhouse.
Yeah, there's a lot of different things. Well, actually, one of my theories on food on Mars is going to be Kimball Musk's. He's got a startup where they grow food in containers, in metal containers, and so you need the energy for the lighting, but you're actually able to simulate the environment, the optimal growing environment for the plants you're trying to grow, based on the history of what you know about. This is when basil grew the best in this particular season, and you can actually mimic the humidity, and you can mimic the temperature and the hours of sunlight, and you can get optimal production of vegetables using. So I think the future of food on Mars is going to be not greenhouse where you're using sunlight, but you're going to be used because I think that's not going to work. And this idea of growing it in either in caves or in containers where you can control everything, and you just use energy, solar energy, nuclear energy, whatever, to generate the light that you need to get the growth you want. I think that's probably going to be a lot more viable. But all these things take a lot of energy. So, but the problem is solved if Elon is sending 1,000 ships to Mars every 2 years. And one of the other things I have one video on this in my latest video. I talk about it again. Right now, we're talking about a 9-meter diameter Starship. Elon has said they're going to have an 18-meter diameter Starship, and it's probably going to carry at least 4 times as much stuff and maybe 8 times as much stuff, and it will probably cost even less per kilogram for what it's delivering to the surface. So I don't know what you think about that. Just your thought. Do you think that Elon solves these problems by just making more starships, making bigger starships, and reducing the cost of delivering mass to the surface of Mars?
I think that would help, but if it takes 2 tons of solar panels and then another 28 tons of batteries, so 30 tons total for 10 kilowatts, and you want to get up to 10 megawatts, now we're talking about 30,000 tons. So that's at least 300 starships. So even if you have 1,000 starships, you're going to send a third of them with just solar panels and batteries. I mean, if you have to do it, I guess you can do it. It's not impossible.
Well, keep in mind what I'm saying. I don't know if you're talking about the colony or you're talking about the initial phase.
No, I'm talking about when you're really trying to scale. You're trying to do mining, you're trying to do manufacturing, you're trying to do construction, you're trying to grow crops. At some point, you're probably going to want to create, even if you do solar panel in the long run, or even build your own nuclear reactors in the long run, you're going to need power to do that, to create a solar power at a battery factory, or to create nuclear light water reactors on Mars. using the locally sourced uranium. So I think even if you do have 300, when you're at the point where you're sending 1,000 starships every couple years to Mars, I think if you're going to use 300 of them and barely have enough to power your colony, I think you would be better off, sending, having a lot more power from nuclear, assuming the governments can supply that much, and then use the difference to. If you are going to do solar panels, create your own solar panel factory.
Well, yeah, I think I think they would have to make a solar panel factory
on Mars.
I think they will have to make a solar panel factory on Mars. I think that's got to be part of the plan. But I just think,
right,
if there's a Starship 2.0, which is an 18 meter diameter, and if it's lowering the cost of delivering mass, and I see this coming. I mean, I think it's probably by 2027 we're going to be sending 100. I think SpaceX is going to send 100 Starship 2.0s to Mars, and that's going to deliver a huge amount of mass. But actually, just talking about solar panels, and I think the same issue with nuclear. I don't know if Mars has the minerals to either. I don't think. Does Mars have uranium? Does Mars have whatever rare earths that we need? What about don't solar panels require rare earths or cobalt or some minerals that are hard to find?
The rare earths I know less about. I know from some satellite mass spectrometry readings, they have found radiation levels that seem to indicate there's uranium there. So we don't know exactly how much or how much refining you'd have to do with it in order to make it useful. But I mean, certainly there's silicon and there's iron and there's probably most of the stuff you would need for solar panels. I suspect there's rare earths, but I don't know how much research has been done into that and where they are. I mean, another thing, even if you're not going to do your main power using nuclear, some of these 1 to 10 kilopower power plants, which incidentally the 10 kilopower one is just light enough to be able to fit not fit, but to be able to be carried by a Cybertruck. So you could, if you find a rare earth mineral deposit or something, you could potentially use a small reactor for mining that, and then carry it back and process it at your main outpost or whatever. Okay. So there's a lot of options, I think.
Okay, just real quick, we have people watching. The idea that led to this video was I love to argue, so I called it Argue with Warren. I believe I posted this on my community page on my YouTube channel, and David agreed to join in. So everybody who's watching, if you ever have something you want to talk about, I call it Argue with Warren because I'm an arguer, but you can see we're being polite. This is not a in-your-face crossfire thing. If anybody has anything, just email me, wredlick@gmail.com, or comment on find a way to message me. Let me know. I love, let's talk about batteries. Let's talk about all kinds of topics. So yeah, I think this is really probably I think I agree with you on one thing. It makes sense to use nuclear if nuclear is ready to go. If some country says, hey, Elon, we know you're setting up this colony on Mars and we have the perfect nuclear power plant for you, I don't think Elon's going to say no. We've got this thing, it's 30 tons, it'll fit nicely in one of your ships. I can't imagine he's going to say no to that idea. I guess I can't imagine it because you never know what Elon's going to do. But if you were going to deliver reliable energy to the Mars colony, I think he's going to say yes. It's just a matter of, hey, I can't count on these countries delivering the nuclear power that I need. So I'm going to plan for solar, and if something else comes along, great. And I think...
I think that's absolutely correct. And I think that's a smart plan, because, I mean, you never know what's going to happen with politics and administration changes and anything else.
Afak brought something up that I should have thought of. He said, can't we use concentrated solar or other manufactured heating? That's a really interesting question. We've been talking about solar panels, but I know there are some major solar projects where they concentrate the sun and a different way to create electricity. And I believe that those concentrated solar farms are more efficient. Is that, I don't know enough about that. I don't know if you know enough about that. That might be a future video. Could you do concentrated solar on Mars?
Right. So I think he was talking about not using it for energy generation, which you can do, although it's debatable whether that's
thank you, James.
More or less efficient than photovoltaics. But if your main goal is not to use it for generating electricity, but for generating heat, for manufacturing or mining or just to heat your base or whatever, then you could use that. And nuclear similarly, most of these, when I'm quoting these numbers, this is in electricity, but they originally create thermal energy, and then they convert it to electricity using some sort of turbine at like a 3 or 4 to 1 ratio. So either way, if you want thermal energy, probably photovoltaics are not the way to go. You could use concentrated solar power, or you could use the first part of the nuclear reactor without the electrical generator attached to it.
Okay, so first of all, I want to say a special thank you to James Knapp. James actually made a donation. I think it's called a super chat. Thank you very much for that. It's only the second video where somebody's done that, and I really appreciate it. For me, this is just a fun conversation. I'm glad you guys are listening. Nathan said, if investing in situ resource utilization for rocket fuel and oxidizer production, that will be like a massive low efficiency battery. Subtract 95% battery mass from equation, solar becomes a lighter option. That you could essentially create, it does sound highly inefficient, but you could create the methane through the Sabatier process, and then if you don't use it for rocket fuel, you could use it to produce energy. That doesn't sound like a good plan, but maybe it makes sense. And that's the other question: is could you make batteries on Mars? Because like lithium iron phosphate, if you're making batteries for Mars initially, you don't care if you're making them on Mars. You don't care about energy density, either volumetric or gravimetric, by weight or by volume. So if you had a fairly inefficient battery you could produce on Mars, as long as it worked, that might be better than shipping batteries to Mars.
Right. So, both of those are a possibility. I think the creating batteries on Mars is probably going to be more efficient. What was the number that he quoted? It's something like 5% efficient.
He said 95%.
Use the Sabatier.
He said massive low efficiency battery. Subtract 95% battery mass from the equation.
Right. So, but you could do that, and if you're just worried about 2 weeks of a dust storm, once a year or something, it's not going to happen very often. Then you could have some extra solar panels. You could take one of the the cargo ship that sent them and start to use the Sabatier process to refuel its fuel tank. Not that you're ever going to use it to launch off, but use it just as a fuel tank. And then when you get your dust storm, you could have a modified natural gas generator powered by methane and oxygen to power your base, kind of like some people use a diesel generator for backups on Earth. So you could do that, and that is something that you might want to do if you want to reduce the 14 days of battery backup to like 1 day. Then you're using your fuel tanks from your cargo Starship as a.
I just want to mention Space Intelligence listed in the chat a large number of elements that have been found, that have been detected on Mars, and they're relatively common. I'm going to go through this list: magnesium, aluminum, titanium, iron, chromium, lithium, cobalt, nickel. Cobalt? Really? They found cobalt on Mars? Lithium, cobalt, nickel, copper. I'm going somewhere with this in a second. Nickel, copper, zinc, niobium, molybdenum, lanthanum, europium, tungsten, and gold have been found in trace amounts. This actually led me to a question that's really fun. We're going to have a fun question, which is, I've seen people talk about asteroid mining, and I'm like, okay, it seems like a lot of work to go out to the asteroid belt or wherever to mine an asteroid and bring it back to Earth. But if you're bringing it back to Mars, that might be a lot more sensible because Mars's gravity well is smaller, so it would be easier to launch from Mars to get things there. It might be easier to bring things down in useful quantities to the Martian surface. Do you think there's Asteroid? I'm going off on a limb here to almost a totally different topic here. But do you think asteroid mining could be critical to the development of a Martian colony? I know we're not talking about solar versus nuclear anymore, but
so mining the asteroid and bringing the materials to
and
Mars?
It could be useful for either solar or nuclear in the process. But I see people talking about asteroid mining, and it's like, well, that's a long way to go to bring stuff back to Earth. Earth's gravity well makes things difficult. But if you're doing things for the Martian surface, because the gravity well is much smaller, and because it's closer to the asteroid belt, I could see where that would make a lot more sense than doing asteroid mining to bring stuff back to Earth.
Right. I think that makes sense. You just listed a bunch of materials that are found on Mars. I think that makes sense for the ones that are not found on Mars that you really need. And so some people have talked about going all the way out to Titan to bring nitrogen back to Mars if you're going to do any kind of terraforming effort, because there's not a lot of nitrogen in the Martian atmosphere. So maybe you could get certain rare materials that you can't find on Mars from the asteroids. That's a possibility. You could also potentially do it the other way if you find some like really cool quartz, diamond, whatever things on Mars that grow bigger or differently than they do on Earth because of the lower gravity. Then at the end of your 18 months, you brought a bunch of food and other stuff with you on the starship. Now you're going back with the starship mostly empty. Maybe you could bring a couple Hope diamonds with you or something.
I would think that just bringing Martian rocks sure. Regular Martian rocks would sell for something. But yeah, it may be that they find some items that would be very valuable on Earth at that, dollars per mass, dollars per kilogram that they could bring back.
Yeah, maybe some unique jewelry things or something. I don't think it's going to be much in the long term, but if you're, as like a passenger, if you're, just bringing a small amount of stuff back with you, then sure.
Yeah, Afak said something, and Afak, I think I'm going to disagree. I hate to disagree with people, but Afak said instead of a generator, they can use a natural gas fuel cell. And I know Elon generally doesn't like fuel cells, so I don't see Elon going for a fuel cell, but maybe in this context he would. Instead of using a natural gas generator, like the diesel we talked about before, you could use a fuel cell. I don't think Elon likes fuel cells. I can't imagine him going for that, but maybe it makes sense on Mars. Yeah. Nicholas says asteroid mining makes commercial sense if it is processed in space. The costs mount up when shifting up and down gravity wells. I agree with that, Nicholas, but I think the point is that the cost is a lot less for Mars gravity well than it is for Earth's gravity well. And you mentioned Titan. I thought that was really interesting about nitrogen from Titan, but I would think that would be a volume problem. That squeezing enough nitrogen, I guess you could compress it.
Hey, you're the one who said that you were going to have 100 Starship 2.0s.
Yeah, but
But yeah, you'd have to compress it.
But enough nitrogen to matter for the atmosphere of Mars would be, now we're talking about millions of starships or billions of starships.
Yeah, this is probably a multi-century project.
I don't think you can manufacture a basic element, so I don't know how that would work. But
fusion.
So what do you think about fuel cells?
I think if you're going to do, you could possibly use it for ground transportation. I don't know that you would use it for base. I mean, maybe you could. I don't know how the math works out that well. Maybe. Certainly, you could, use the Sabatier process to create liquid methane. Again, I would, at least to begin with, I would store it in one of the cargo starships fuel tankers, and then use that as a gas station. So you could use it to power your base either through fuel cells, I guess, or through some kind of generator. And then certainly you could use it for if you wanted to do natural gas ground vehicles or bulldozers or any kind of mining equipment or whatever. I suspect you can probably do the same with electricity, but I don't know of any bulldozers or cranes that work purely on electricity today. So that would be a little bit of probably methane or fuel cells would be a little easier.
Okay, a couple comments here. Eldon made a couple comments about methalox, that Starship would have tens of tons of it in the Starship's tanks. And Gareth, I'm not sure, Gareth, where you're going with railgun. He says railguns work very well everywhere except on Earth. I'm not sure what we're doing with railguns on Mars. I love the railgun concept. But I don't, Eldon, if you can explain what we're doing with the methalox, I didn't quite get that unless you already know what he means, David. Okay, so you don't know what he means. And then Gareth, same thing. I appreciate that railguns were, I love the concept of railguns. I'm not sure what we're doing with them. How are we using railguns to make a difference with what we're trying to do on Mars? I didn't get that.
You could, so you could use a, well, I think by railgun, I assume he means a mass accelerator. Yeah. So, right. So you could potentially use that to bring materials from Mars into space. If, I don't know, maybe you're going to do some manufacturing on Mars, and then you're going to, leverage that to colonize the, the asteroid belt or the outer planets or something, I guess.
Okay. All right. Well, listen, we've gone for over an hour. I really enjoyed this conversation. I want to stress to people again, if you're watching, this was the concept is the Argue with Warren video series. If you have a topic you want to talk about, especially if you watched my videos and you disagree, like, I think robotaxis are going to take over the Earth. I think we're going to see Tesla vehicles with smaller battery packs, not larger battery packs. I was arguing with somebody today. He says we're going to see 1,000-mile battery packs. I say no, we're going to see 250-mile battery packs, because then you can make 4 times as many vehicles. So I love arguing these topics. Whether it's how is solar going to be deployed on roofs? Is SpaceX going to go to larger rockets? What about the Boring Company? You want to talk about anything you want to talk about? If you have an idea for something you want to discuss, we'll have this kind of back and forth conversation. If it's not you, if you don't want to be David was kind enough to not only suggest the idea, but to step up and be on camera. If you have an idea and it's not you, but you know somebody who wants to be a part of that conversation, I'll step on camera for anything. I love this stuff. So if you have something in mind that you want to bring up, just contact me, say, hey, Warren, let's talk about this. And we'll have a conversation like this. David, I want to thank you so much for, number 1, suggesting the idea, number 2, coming on with me. Anything at the end you want to say before we say goodbye?
No, thank you very much. This was great.
Okay. Thanks very much. Goodbye, everybody.
And I'm a big fan of your work.
Oh, thank you. Bye.